Hello everyone, very good evening. Kindly confirm if audio video is clear. Okay, yeah, everything is clear. Very good evening everyone. Let's start the discussion on this topic of database management system. So guys, I am going to start a series for this subject, database management system, and in this series I will be discussing the concept of query languages. So, one thing is guaranteed that if you attend all these sessions sincerely, then you will be able to solve each and every question asked in the GATE exam related to query language. But the only thing that is required is that you must be regular, you must be learning all the concept with full attentiveness. So, that will be the prime requirement. And there are certain things which you must understand related to query languages. In the very beginning, when you start solving the questions of query languages, some of them will be very easy and some of them will be take a lot of time. So it's perfectly fine if some of the questions are taking longer duration before you understand those questions, because especially in terms of structured query language, the concepts are very easy, but in order to analyze the questions, that what is being asked, how to approach that particular question, you will require some time before you become pro in those particular types of questions. So the prime requirement of the query languages is going to be that you give sufficient amount of time to each and every question, so that you understand that what type of questions can be asked in the GATE exam and how to approach them. That will be the very first thing that you must understand, right? So as you all are here, I hope we can start with the discussion of this or query languages. So first we'll try to understand that what are the different types of query languages that I will be including in this series. Okay, and today we'll start with the first type of query language, that is relational algebra. It's actually a formal query language. Why do we call it a formal query language? Because it is a procedural query language. So we'll try to understand that what is the difference between procedural query language and a non-procedural query language. Okay. And then in the basic relational algebra, today, we'll complete the discussion of basic relational algebra operation. That what are the basic relational algebra operations available in relational algebra. So there are two types of operations. Some are basic relational algebra operations, and some of them are derived relational algebra operation that will be derived using this basic relational algebra operation that we will be discussing in the today's session. Right. So please make sure this is the general doubt of the students. Will we cover all the topics of database management system in this series? No. So please try to understand. We also have limited amount of time. So we in this particular, so the only idea is that we will discuss the complete database management system, but may not be in a single go. So let me complete one topic of database management system, that is query languages, in this particular series. Then we will start some other series of the database management system, in which we will discuss the remaining topics of database management system. So we will not cover all the topics in one go, but yeah, we will try to cover each and every topic of database management system, maybe in parts. Okay, so one thing is guaranteed, that I'll cover all the topics of query languages in this particular series. So there will be no question that you will not be able to solve after attending all these sessions of this series. So having said that, let's start with the very basic concept, that sir, what do you mean by query languages? So query languages are used for what purpose? Sir, query languages are used to query the database. If you want some information which is present in the or which is stored in the database, and you want to retrieve some specific information from the database, then to retrieve that information from the database, different type of query languages can be used, and for different query languages, the query writing style will also be different, and obviously the language is different, so writing style is going to be different, right? So that's what we are going to cover. But basically, if somebody asks me that, so what are the broader classification of the query languages, so I can eventually classify query languages broadly into two categories. One will be procedural query language. So I'll not write all the definitions, but if you are a sincere student, then you will understand with this information only, right? So procedural query languages. So procedure, we will eventually define the procedure. What does it mean? Rightly said by Pratik, sir, we will define that what to retrieve from the database. And at the same time, we will also define that how to retrieve that information from the database. Clear? So two things will be there. Procedural query language will be first, what to retrieve, from DB, and second, how to retrieve. So this is process that will be followed to retrieve the information from the database. Are you sure? Yes. Chale. If we talk about non-procedural query language, so another type of classification will be non-procedural query language. Sir, we only define that what to retrieve from the database, and the query language will provide the syntax to retrieve the data from the database. So here we'll understand the mathematical model. If you talk about procedural query language, then it will be a mathematical model that how actually the database will be queried to get the required information from the database. But when we talk about non-procedural query language, then there are some predefined syntax. So when somebody asks you that, sir, I'm not comfortable with structured query language. If somebody tells you that I'm not comfortable with a structured query language, then the simple logic is that he does not understand the concept of syntaxes available with the structured query language. What is the meaning of with clause? What is the meaning of as clause? What do I mean? Or what are the limitations on the information that can be selected in the select clause? Just like that, we will talk about that in SQL, you cannot select any other attribute along with the aggregate function until that attribute is present in the group by clause. So if you do not understand this simple syntaxes related to a structured query language, then you will not be able to solve the equation of SQL. So we'll talk about all the valid syntaxes in SQL. At the same time, we'll also talk about invalid syntaxes in SQL, so that you will be able to understand that what is right, what is wrong, what you can, what can be used to retrieve the data from required data from the database, and what will be an invalid syntax if you do so. Okay. So non-procedural query language basically defines only one thing, that what to retrieve from the database. You only define what to retrieve from database, and we use syntax provided by query language. We don't know that how exactly that information is being retrieved in our non-procedural query language. We only use the syntaxes. So what are the examples? If somebody asks me that, sir, what will be the example of procedural query language? Sir, it will be relational algebra. And if somebody asks you the examples of non-procedural query language, sir, SQL is a non-procedural query language. Many of you may think that SQL is a procedural query language, but SQL is a non-procedural query language. Okay. Apart from that, relational calculus is also non-procedural. So there are two types of relational calculus model: tuple relational calculus and domain relational calculus. So that's the basic thing. These are the things which we are going to cover in this particular series. Okay. Query languages, procedural query language, non-procedural query language. What do I mean by procedural query language? That will define that what to retrieve from the database, and at the same time we will also define that how exactly that information will be retrieved from the database. But in non-procedural query language, we will only know that what to retrieve from the database, and we will use the syntaxes provided by the query language in order to retrieve the required data from the database. Okay, sir. So our main focus in the today's session will be on relational algebra, because if I tell you, then relational algebra is basically the prerequisite to understand structured query language and tuple relational calculus. So in the syllabus, generally they have not asked any question related to domain relational calculus till date. They have only given one question in which one of the option in the question was from domain relational calculus, but there is no direct question from domain relational calculus that has been asked till date in the GATE exam. Therefore, my primary focus in this series will be relational algebra, structured query language, and tuple relational calculus. So, first we'll complete all the topics of relational algebra, because relational algebra will provide you a mathematical model based on which all other query languages are defined. So, if you know relational algebra, you will be able to see that what is equivalent to projection of relational algebra in SQL, what is equivalent to selection of relational algebra in SQL, and you will be able to understand other query languages as well if you know relational algebra in proper manner. So the very first thing is the discussion of relational algebra. So if I ask you, sir, what do I mean by relational algebra? So all certain things first. So it's a procedural query language. No need to write. But still, what is more important? Is a procedural query language, and moreover, it works on the relations. It works on the relation, right? So when I say it works on the relation, in the relation, the basic definition of relation is that no duplicate tuples are allowed in a relation. So if no duplicate tuples are allowed in a relation, and it is a relational algebra, so you must understand that relational algebra query will always produce distinct tuples. That's very important. So it is a procedural query language. Apart from that, if you write any relational algebra query, then it will always produce distinct tuples. There will be no duplicate tuples. What is more? What is another thing, sir? When you write a query, and if a query condition is evaluated, then the important thing to understand from the relational algebra or any query language point of view is that query condition evaluates tuple by tuple. What's the idea? Whatever the condition is, that particular condition will evaluate tuple by tuple. We'll first take the first tuple and we'll see whether first tuple should be selected or not. Then we'll take the second tuple and we'll see whether the second tuple should be selected or not. Then we'll take the third tuple and we'll see whether the third tuple should be selected or not. So the idea is query condition evaluates tuple by tuple, taken one tuple at a time. So at a time, you can see the content of only one tuple. So the idea is, what will happen if you want to compare two or more tuples of the same tables or of different tables? So if you want to compare two or more tuples of the same table or different tables, then you will have to combine those tuples into a single tuple. You will have to combine those tuples into a single tuple. If you do not do so, then you will not be able to compare two different tuples of the same table or of different tables. So that's the very important thing, that query condition evaluates tuple by tuple. If you do not know, if you are very naive to the concept of relational algebra, then please try to understand each record of the relational table is called a tuple. Each record of the relational table will be called tuple. So query condition evaluates tuple by tuple taken one tuple at a time. How many? Taken one tuple at a time. Therefore, so if you cannot work on two or more tuples at the same time, then if at all you want to compare two or more tuples, therefore, if we want to compare two or more tuples, if we want to compare two or more tuples of the same table or different tables, of the same table or different tables, then what is important? Then we need to combine those tuples into a single tuple. Then we need to combine those tuples into a single tuple. And how do we combine? How do we combine them? For that purpose, we use the concept of join operation or cross product. For that purpose, we may use join operation or cross product. This is one of the most important thing, right? Relational algebra query will always produce distinct tuple. If you talk about SQL, then SQL may produce duplicate tuple if you do not use the keyword called distinct. Okay. If you use distinct keyword, then SQL query will also produce distinct tuples. But if you do not use distinct in SQL, then it may produce duplicate tuple. But whereas relational algebra by default will produce distinct tuple. And another thing, that query condition will evaluate tuple by tuple, taken one tuple at a time. If you want to compare two or more tuples, you will have to join them. You will have to join them into a single tuple. Anyway, okay. We'll talk about operations in a while. But another important thing is that given some relational tables, the very first thing that you must understand is that what information is available in which table. If you are not able to identify that the required information is available in which particular table, then you will not be able to write the query. You will not be able to trace the given query, right? So, for the purpose of explanation of relational algebra, I am going to take these three relations. One is a supplier relation, another is a relation named parts, another is a relation named catalog, right? So let's try to understand that what information is available in these tables. So supplier is a relation. SID is a primary key of this relation. If something is underlined, then that particular attribute will become the primary key of that particular relation. So SID is a primary key of that relation. What does it mean? That SIDs will be unique in this relation. It is not possible that there are two similar SIDs present in two or more tuples. Not possible. So SID will be unique. S name may be same, may be different. We don't know. Rating may be same, may be different. We don't know. Right. So supplier is a relation in which we have the information, that is what is the ID of the supplier, what is the name of the supplier, and what is the rating of that supplier. So these are the three informations available in this supplier relation, where SID is the primary key. Another relation is parts, which contains the information about parts, that what is the ID of the part. So it's okay, sir, every part has a unique ID, but the colors of the part may be same. Colors of the part may be same. So part table is having two attributes. One is ID of the part and another is color. So it may be possible that two different parts have the same color. Okay. Sir, what is this catalog relation? What is this catalog relation? So the catalog relation contains two information. SID, that is what is the ID of the supplier. PID, that what is the part ID of the part, and the cost at which the particular part is supplied by that particular supplier. So do you realize that in catalog relation, these two attributes together, SID and PID, SID and PID form a primary key. What does it mean? Sir, SID and PID form a primary key means together the value of SID and PID must be unique. Together the values of SID and PID must be unique. It may be the case that there are two SIDs, there are two similar SIDs. It may also be possible that there are two similar PIDs, but the tuple wise the values of SID and PID will be unique. So you can actually see, if you have S1 P1 in the first tuple, then you cannot have S1 P1 in any other tuple of the catalog table. You may have S1 at some other place, you may have P2 here and P2 in this tuple, but S1 P1 together will not appear anywhere else in this catalog relation. Similarly, S1 P2 will not appear anywhere else in this relation catalog. S2 P2 will not appear anywhere else in this relation catalog, etc. So the idea is SID and PID together will be unique. SID, PID together will be unique in this relation catalog. So what information is available in which relation? So IDs of all the suppliers along with their name and rating is present in the supplier relation. IDs of all the parts along with their color is present in the part relation. And in the catalog relation, we have the information that which particular supplier has supplied which part at what cost. Clear? So these are the different things which are available in these three relations. Now let us try to understand. These are the, so this is the skeletal that I am going to use to explain the complete relational algebra. These are the three relations which I will be using to explain different concepts of relational algebra. All the questions will be framed on this three relations only. Now you can generalize it for any type of relation, but I will be explaining all the concept using these three relations. The simple reason is, if I keep changing the relation, you will not become comfortable with the concept, because most of the time will be wasted in understanding the information that what is present in which relation. Therefore, I'll keep relations same, but the data that we need to retrieve from this database will keep changing. Okay. So now we know that we are going with a procedural query language, that is, we will define the procedure that how exactly the information will be retrieved. The required information will be retrieved from the database. These are two important concepts. Please remember, the relational algebra query will never produce duplicate tuples, and the query condition will evaluate tuple by tuple. That is, whenever we want to compare two or more tuples, then we will have to join them into a single tuple. Otherwise, it is not possible. Please remember that. Right? Now, the very first type of operation will be projection operation. But let me define that relational algebra operation can be classified into two types. There will be two types of operations. One is basic relational algebra operation, another is derived relational algebra operation. What do I mean by derived relational algebra operation? Sir, they can be derived using basic relational algebra operation. What are they? So there are 6 basic relational algebra operations. First one will be projection, another one will be selection. I'll explain each one of them, don't worry. Then third one will be cross product, union, set difference and rename. Union, set difference and rename. These 6 are the basic relational algebra operation. 3 derived relational algebra operations are subtraction, join and division. So there are 3 derived relational algebra operation. One is intersection, another is join operation, third one is division operation. We will not talk about these 3 operations in the today's session because it's enough if we can understand all these basic relational algebra operations in the today's class. So one by one, we'll try to cover all the topics of relational algebra and then we'll cover all the topics of SQL. But first, for today's session, we'll be discussing all the basic relational algebra operations. So we'll complete all the basic relational algebra operations in this class. So first one is projection. First one is projection. So let me explain that what happens. Sir, a relation may have many attributes. Like if I talk about supplier relation, in the supplier relation, we have the information about supplier ID as well as name of the supplier as well as rating of the supplier. It may be the case that I am not interested in all those informations. I am interested only in the SIDs of the supplier. I only want to know that what are the different SIDs of the suppliers in the supplier table. Then the information related to S name and rating will be redundant in your output. You will have unnecessary information in the view if you are projecting all the information or if you are projecting the information related to all attributes in the output, intersection operator and division operation. Yeah, join is also there. Join is also there. Chale. Let's talk about first operation, that is projection. So why do we use projection? If I want the information related to specific attributes only, if I do not want the information related to all the attributes of the relation, then we will use a projection operation. So it is used to project the column data. You may be asking that, sir, why we have this information written on the slide, why are you not writing? Because we need to complete as much syllabus as possible, right? So it's perfectly fine if I save some time while explaining the concept. So it is used to project the column data. Column data means information specific attributes. It is used to project the column data from a relation based on, sir, you will get the data from which particular column? You will get the data from the column which you have specified along with the projection operation. So how do we write this? Sir, we write, so symbol for the projection operation, this will be this pi symbol. So you will have the projection, then from which relation you want to project the information in the output and the list of attributes corresponding to which you require the information in the output. So anyway, please look at this. This is your supplier table. If somebody asks you to retrieve the SIDs of all the suppliers, so it will be a simple concept. For projection of SID, you will use projection, but please try to understand. It is very important to learn that in what order the query will evaluate, right? So first of all, you will take the supplier relation. You need the information from supplier relation. you need the information from supplier relation. So first of all, you will take the supplier relation. Then from that supplier relation, you will project what is required. Sir, you only require the SIDs. You only require the SIDs of the supplier. So in the output, you will get only SIDs. Wait a minute, I'll explain other things as well. In the output, you will only get SIDs, that SID S1 is present, SID S2 is present, SID S3 is present, SID S4 is present, SID S5 is present, etc. But at the same time, if I ask you for the different ratings, retrieve different rating from the supplier relation, then what will be the output? Sir, in this case, from the relation supplier, we need what information? Sir, we need rating of the supplier. So, sir, what is new in this specific case? So, all SIDs in this table are unique. Therefore, in the output, you will get all the SIDs. But when you talk about rating, there may be duplicate ratings in the supplier table. As you can see, 3 appear only once, so it's perfectly fine. 5 appear only once, so it's perfectly fine. 7 appear only once, it's perfectly fine. 0 appear only once, it's perfectly fine. This extra 0 will not be present in the relation. This extra 0 will not be present in the relation because relational algebra query will always produce distinct tuples. Yeah, it's fine. Perfectly okay if I leave it at this stage. Okay, come on, let's learn some more things. So what if I write something like this? So is it necessary to project a single column from the supplier table? No, sir. If you want, you can project all the attributes all together. You can project all the attributes all together. So from this relation supplier, you can project SID as well as SNAME as well as a rating. If you do so, what will happen? So the output of this particular query will be complete supplier table. Output of this query will be complete supplier table. Output will be complete supplier table. Now, if you need all the attributes from the supplier table, is it really necessary to project all of them by writing or by listing them explicitly? No, sir, it is not necessary. No, sir, it is not necessary. If you simply write supplier, then also all the tuples from the supplier relation will be present in the output. So both of them are same. If you project all the attributes explicitly or you simply write the name of the supplier, the behavior of both the queries will be same. Clear? So that's one thing. I hope, so I'm trying to explain each and every concept from the very basic. Some of you may think that's we already know the concept of projection. So if you already know the concept of projection, if you already know the concept of selection, if you already know the concept of cross product, you may have to wait for one class before I actually move on with some practical type questions of the relational algebra. But there may be some students who do not know anything about relational algebra. So for them to become a part of this series, first of all, I'll explain all the basic concepts and then we'll move to the higher level questions. Clear? So that's it. Another thing is, sir, projection does not obey the concept of commutative property. Why? Please, if you first project certain attributes from relation R, then you project another list of attributes from the output of this in a relational algebra query, then it may be the case, that the attributes which are present in list 2 are not at all present in list 1, Same work as on SQL, select distinct S name rating from supplier. Yeah, although rating 00 is not distinct, the tuples as a whole, that's why. What are you trying to ask, Siddharth? Although rating 00 is not distinct, yeah, but the tuples as a whole are unique, right? You may, okay, you are talking about this, that if you are trying to say that, sir, the values cannot be unique, but the tuple wise, we are just saying that the duplicate tuples are not allowed. That means if S4 𝐂𝐚𝐴0 is available, then we cannot have any other tuple with the values S4 𝐂𝐴 and 0. So this will be a duplicate tuple. So it is not allowed, but some of the values may be repetitive. So it's perfectly fine. You write in that manner. That's okay. Clear? So same work on SQL. Yes, obviously. So here what I'm trying to say is, let's assume if I take the relation supplier, then I project something like, let's say, SID and S name. And from this, if the list 2 is SID, it may be perfectly fine. It will work. But what if from relation supplier, let's swap this to list of attributes. First select SID. If you have first selected SID, or first you have first projected SID, then at the later point of time, if you try to project SID and S name, will it be possible? So it will be invalid. Yes or no? So earlier I did not explain because you may not know the concept that what actually I mean by this list 1 and list 2, right? So it's a simple concept that projection will not obey the commutative property. The order in which you project the attribute is important. So if your outer list of attribute is a subset of inner list of attribute, then it will be valid. But if your outer list of attribute is a superset, not equal, is a proper superset of inner list of attribute, or contain any attribute which is not present, or basically we can say is not a subset of inner list of attribute, then the projection in this manner will not be allowed. Clear? So now we understand the concept of projection. Let us try to understand the second basic relational algebra operation, that is selection. Let us try to understand the second basic relational algebra operation, that is selection. So when we were using the projection earlier, we did not worry about the tuples which are present in the output. If you want to select some specific tuples from the relation, the word itself says, if you want to select some specific tuples from the relation, then you will use a selection operation. So for the selection of some specific tuples from the relation. Now, how does it work? So it is denoted using this. So from relation R, if you want to select some particular tuple, then define the condition based on which you want to select the tuples from that relation. Right? So simple. So what will happen? So if you use the selection condition, then it will only select the tuples for which the predicate condition is specified along with the selection operation is true. Clear? So it is used to select the tuples from underlying relation based on the predicate condition specified with selection operation. So you will define the relation, selection operator, and the condition based on which you want to select the tuples. We will talk about this in a while. But let us first try to understand the concept. So if I ask you that select the tuples in which the cost is greater than or equals to 20. So I think the cost has to be greater than or equals to 20. Position display column and selection display. Just 1 minute. EduIT views will understand it in more detail. It does not display. Selection will select the tuples, and the job of display will still be done by the projection. Clear? So selection will only be used to select the tuples based on certain condition. If you want them to be present in the output, you may have to use projection operation if you are interested in a specific attribute. Clear? We'll see it in a while. Please. Let's look at this question. Let's select the tuples in which cost is greater than or equals to 20. So we'll simply say that from which relation I want to select the, okay, this is catalog relation. This is the only relation which contains the attribute cost. So first of all, we'll select the tuples in which cost is greater than or equals to 20. If this is the case, what will be the output? Let me rewrite this. If this is the case, sir, what will be the output? In this case, the output will be, sir, because we have not used any projection operation. Look at this carefully, everyone, and EduIT view. Because we have not used any projection operation, therefore, the output of this relational algebra query will contain all the attributes. So you will get SID, because SID attribute is also present in the catalog relation. PID attribute is also present in the catalog relation, and cost attribute is also present in the catalog relation. Therefore, output will contain all the attributes SID, PID as well as cost. So S1, P1, sir, equals to 20, therefore it will be selected. S1, P2, it is greater than 20, therefore it will also be selected. S2, P2, 25. It is also greater than 20, therefore it will also be selected. But this cost 10 is less than 20, therefore corresponding tuple will not be selected. Now, sir, here we will display all the attributes. But if you want to display a specific attribute from the selected tuples, then you will have to use an extra projection operation along with that. So if I do not say select the tuples in which the cost is greater than 20, but if I say retrieve now you are only interested in the SID. In this case, you are only interested in the SID. So after selecting the tuples in which the cost is greater than 20, you will further go and you will project the required attribute. So in the output, this time you will have only attribute SID corresponding to the selected tuples. This 3 tuples were selected because of this inner relation algebra query, and from this 3 selected tuples, SID will be projected. So you will only get S1 and S2. Why? So second time S1 will not be projected. Make sense? Second time S1 will not be projected. If you see the complete set of attributes, then S1 P1 20 is different from S1 P2 30. But here S1 and S1 are same. Therefore, they will be displayed only once. So can we start preparation of DBMS with this class? SD core. You can, if you have some basic knowledge, if you have some basic knowledge related to relation. Not more than that is required, but you must understand what a relation is. Though I am explaining that concept repetitively, but still, if you do not know anything related to relation, then it may be difficult. If you have completed your graduation, or if you have studied database management system in your university course, then also it will be sufficient, or then also you will be able to understand each and every concept discussed in this particular series. But if you have not studied database management system at all, then this may not be the right order to complete the database management system. Yeah. Chaliye. Okay, sir. So I hope you understand the selection condition. Now, sir, selection condition will obey the commutative property. That means you can say first you can check for condition A and then for condition B, or you can first check for condition B and then you can check for condition A. So that's the idea. I hope that's perfectly fine. That from relation R, if you want to select something based on condition A and B, so whether you first select the tuples based on condition A and then you select the tuples based on condition B, or first you select the condition, first you check for condition B and then you check for condition A, will be exactly same thing. Therefore, there will be no problem. Then it's fine. You can do SD code. Clear? Now, if this is the thing, then this can also be written in this particular manner. So what will happen? Sir, you are actually trying to say that select the tuples from relation R in which condition A is true as well as condition B is true. So rather than saying that select the tuples in which condition A is true as well as condition B is true, you can also say that select the tuples for which condition A is true, and out of those tuples in which condition A is true, check what are the tuples in which condition B is also true. So basically you are selecting the tuples in which condition A as well as condition B is it true? Yes or no? So these two are same. That first, if you select or if you check for condition A and B at the same time, or if you first select the tuples in which condition A is true, then you select the tuples in which condition B is true, is the same as selecting the tuples in which both condition A and B are true at the same time. Clear? Similarly, if you are first selecting the tuples, or if you are selecting the tuples in which both B and A are true, then you can first select the tuples in which condition B is true. Then out of those tuples, you can select the tuples in which condition A is also true. So what will eventually happen? Sir, in this tuples, condition B is true, then the output produced by the outer selection will be the tuples in which condition A is also true. So basically, in the resulting tuple, both condition A as well as condition B will justify. So that's the idea. But you cannot write this thing in the similar manner for OR operation. If it is OR, then how do we denote this? Come on, let's see. If I say select the tuples in which either condition A is true or condition B is true from relation R, then this is exactly same as the concept that select the tuples in which condition B is true or condition A is true from relation R. So these two are equivalent. But with respect to AND, you can represent them in this particular manner. But with respect to OR, this will not be the appropriate choice. Sir, here, condition A as well as condition B, both must be true. But in this specific case, either condition A should be true or B should be true or both can be true. Therefore, the representation for this will be somewhat different. So what will be the representation? You will have to select the tuples from relation R in which condition A is true, or select the tuples from relation R in which condition B is true. Right? So either you will write it like this, or this will be commutative. Therefore, you can first select with respect to condition B, then you can select with respect to condition A. So this will be select the tuples from relation R in which B is true, or select the tuples from relation R in which A is true. Is it clear to everybody that with respect to AND, we can represent the relational algebra query in this particular manner, but with respect to OR, we'll have to represent the relational algebra query in this particular format. Is it clear to everybody? If we represent in this particular manner, then it will be the representation of AND. This, for with respect to OR, you will have to apply the selection operation explicitly. You will have to apply the selection operations explicitly. So that's it. We are done with the selection as well. Let's try to understand about cross product. Sir, what is cross product? Very easy, sir. Sir, it is a binary operation. Till now, whatever operations we have seen are unitary operations. Selection operation can be performed on a single relation. Projection operation can be performed on a single relation. But Cartesian product or the cross product must be applied on two relations. Maybe same, maybe different. Maybe same, maybe different. So cross product is a binary operation. Is a binary operation. If you have two relations R and S, let's assume R and S are any two relations. R and S are any two relations. Then cross product R cross S. Then cross product R cross S will do what? So it will result all the attributes of R followed by all the attributes of S with all possible combinations of tuples from R and S. Sir, the definition may not be useful. Let me explain in terms of example. So let's try to understand. This is your catalog relation and this is your parts relation. If somebody asks me that what will be the cross product of catalog cross parts. So what did I say? So let's say this is your relation R and this is your relation S. So if you need R cross S, if you need difference between cross and join, yeah. So I'll explain it in a while. The difference between cross and join are of different types. There may be different types of join operation. It may be natural join operation. It may be theta join or conditional join. It may be equi-join. It may be left outer join. It may be right outer join. So join may be of different types. Join may be of different types. But the cross product is also a join. Cross product is also a join which is known as cross join. Cross product is also a join which is cross join. So Cartesian product or cross join are the same thing. But if certain other selection criteria or if certain other selection conditions are applied on the cross product, then different types of join are derived from the cross product. Please. So there will be other things that we will discuss as time goes, but for time being. So what did I say? There will be all the attributes of, so catalog.sid is one attribute, catalog.pid is another attribute, catalog.cost is another attribute. Then, so these are all the attributes of catalog. Then we will have attributes of parts. Parts.pid is the attribute of parts. Parts.color is the attribute of parts. So what did I say? All the attributes of R, that is catalog, followed by all the attributes of S, then all possible tuples or all possible combination of tuples from R and S. What does it mean? 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 Come on, look at this. Look at this. Sir, if at all you want to compare, S1 P1 with 20, then you may want to compare S1 P1 20 with P1 red. You may want to compare S1 P1 20 with P2 green, or you may want to compare S1 P1 20 with P3 red. So generally, join or cross product is used for joining the tables such that the comparison or condition can be evaluated. So the idea is, sir, S1 P1 20, you may want to compare this S1 P1 20 with P1 red. You may want to compare this S1 P1 20 with P2 green. You may want to compare this S1 P1 20 with P3 red. Yes or no? At the same time, you may want to compare this second tuple with one of these tuples of part. So you may want to compare S1 P1 30 with a P1 red. You may want to compare S1 P1 30 with P2 green. You may want to compare P1 P1 this has to be P2. This P2, sorry, this P2. You may want to compare this S1 P2 30 with P3 red. Similarly for other tuples, so you may want to compare S2 P2 25. You may want to compare S2 P2 25, S2 P2 25. So it's like cross product in the discrete mathematics or Cartesian product. It's the same thing. So you may want to compare it with P1 red. You may want to compare it with P2 green. You may want to compare it with P3 red. Similarly, the last tuple, that is S3 P3 10. You may want to compare this with P1 red, or you may want to compare this with P2 green, P3 red. So as of now, I am not defining any condition criteria, but I am just trying to define the cross product. So what happens in cross product? Sir, in cross product, R cross S, you will have all the attributes of catalog. These are what, sir? Attributes of catalog. That is attributes of relation R, followed by attributes of S, that is parts, with all possible combinations of tuples from one more thing. Sir, if there are X attributes in relation R and Y attributes in relation S, then overall there will be X plus Y attributes in relation R cross S. Similarly, if there are M tuples in relation R, if there are N tuples in relation S, then overall there will be M. Each one of this M tuple will be combined with N tuples. So there will be M into N tuples in R cross S. Clear? Yes, Siddharth. Once we have joined these two relations, whatever condition, whatever comparison you want to do with the tuples of catalog, with the tuples of part, that can be done. That can be done. Clear? Come on. So that's the joint thing. And that's what I said. Whenever you want to compare, whenever, that's an important thing, that query condition evaluates tuple by tuple, taken one tuple at a time. Therefore, whenever you want to compare two tuples of the same table or two different tables, you will have to join them. How do you join them? Sir, you join them using join operation or cross product. So cross product is also cross join. Cross product is also cross join. Cross product is also cross join. Don't worry about that. When we reach to the join operation, I'll explain. When we reach to the concept of join operation, I'll explain that cross product is a cross join operation. You don't need to worry about it. I'll not skip anything. I'll not skip anything. Now, come on. If these are the two relations, catalog relation and part relation, if I ask you one thing, that retrieve the SID of the supplier who supplied some red color parts. Retrieve the SID of the supplier who supplied some red color parts. Come on, that's the another thing. Sir, you must understand that the required information is available in which particular table, or the information required to get the required data will access what all different relational tables in the database. So you look at this particular query that retrieve SID of the supplier who supplied some red color parts. So it's perfectly fine that SID that the supplier with SID S1 has supplied a part with PID P1. But in catalog table, do we have the information about the color of part P1? That's important. Sir, in catalog table, we have the information that which particular supplier has supplied what particular part. But we don't have the information related to color of that part in the catalog table. So you are actually interested in knowing that if S1 has supplied part P1, then what is the color of part P1? Then what is the color of part P1? So with respect to this first tuple of catalog, that is S1 P120, you are actually interested in knowing the color of this part P1. You are actually interested in knowing the color of this part P1, because if the color of part P1 is red, then S1 has actually supplied a red color part. But if color of part P1 is not red, then with respect to this particular tuple, S1 did not supply a red color part. Got the idea? So you want to compare this tuple S1 or the first tuple of catalog table with the other tuples of the part table to check the color of the part with respect to PID present in this particular tuple, right? So what should we do? You want to compare the tuple of catalog table with the tuple of part table. Therefore, simple concept is that you will have to perform the cross product of catalog with the parts. Once you have performed this cross product, you will have this table in your hand. Once you have performed the cross product, this is what will be available in front of you. Now you want to check what? Sir, if S1 has a supplied part for, look at this, sir, if S1 has a supplied for part P1 and the color of part P2 is something, then what's the use of this particular tuple when the part IDs are different? If supplier has supplied part P1, then we must be interested in the color of part P1. We must be interested in the color of part P1. Yes or no? Supplier has supplied part P1, you are looking at the color of part P10. What's the point of this? If the supplier has supplied part P1, then look for the color of that part P1. Look for the color of that part P1. So once you have performed this cross product, you will be able to see that whatever PID is available in the catalog table, the same PID should be available in the part table in the corresponding tuple, so that we can check the color of that part. Right? If the PIDs are different, if supplier has supplied part P1, if the supplier has supplied part P1, if the supplier has supplied part P1 and you are looking for the color of part P3, then this will be wrong thing to do, right? So that's it. So what should be the condition? Once you have performed the cross product, you must learn that how to write the condition. You must learn that how to write the condition. So the condition will be that in this cross product, whatever the PID is present in a tuple of this cross product with respect to catalog, so whatever the PID in the catalog side, whatever the catalog.pid is, that same PID must be available into parts PID. So this must be equals to parts.pid, because if PIDs themselves are different. If PID themselves are different, then what's the point of checking the color of that particular part? But if at all the PIDs of parts are same, if at all the PIDs of parts are same, then you must check that what is the color at the part side. So if the color is a red, then it's perfectly fine, because we are looking for the suppliers who have supplied some red color parts. So if the color is also red, then what does it mean? If the color is also red, then it means you have selected a tuple in this cross product. You have selected a tuple in this cross product where the SID is available in which the part that has been supplied by that supplier is of red color. So this will be selected, sir. PIDs are not same, this will not be selected. PIDs are not same, this will not be selected. S1, sorry, P2, P1 will not be selected. P2, P2 will be selected, but color is not green. Color is not green, therefore this is also not selected. P2, P3 not selected. Sir, P2, P1 not selected. P2, P2 okay, but color is not equals to green, therefore it is not selected. Now, P2, P3 is not equal. S3, P3, P1 not equal. P3, P2 not equal. Sir, P3, P3 equal. Let me write this. Sir, P3 equals to P3 and color is also red. Color is also red. So two tuples will be selected, first tuple and last tuple. Two tuples will be selected, first tuple and last tuple after this selection condition. So in those two tuples, the SIDs available are with respect to suppliers who have supplied some red color part. So from that cross product, if and from that cross product after selecting the tuples satisfying this condition, if we project the SID present at the catalog side, if we project the SID present at the catalog side of the relation, then I'll get the answer. Yes or no? Is it clear to everyone? Yes, sir. That will be the thing. So, Cartesian product will do what, or cross product will do what? Sir, cross product of two relation will combine each tuple of the first relation with each tuple of the second relation, so that whatever condition you want to check can actually be compared in the cross product. Without this cross product, comparison is not possible. Without this cross product, comparison is not possible. Okay, now, sir, we have seen three basic relational algebra operations. One is projection, selection, cross product. Now, two of them are union and set difference. Sir, union, set difference and intersection are set operations. Union, set difference and intersection are these three. Union, set difference and intersection are the set operations. When exactly set operations can be performed in the relational algebra? So, to use the set theory operators or any two relation, the very prime requirement is that those relations must be union compatible. Those relations must be union compatible. So what is this union compatible? Two relations are said to be union compatible if following two conditions are satisfied. Two relations are said to be union compatible if following two conditions are satisfied. So first says the same degree. So students who are not from, who have not yet seen the concept of relations or relational DBMS must understand the degree is the number of attributes in the relation or the number of columns in the relation. So the first requirement is that the number of columns in both the relations must be same. It is not possible that one relation contains two columns, another relation contains three columns. They cannot be union or cannot be performed any set operations on them. So this degree is also known as arity. Yes, degree is also known as arity that you will discuss in relational model. So same degree must be same. That is, two relations must have the same number of attributes or columns. If you do not know attribute also. Apart from that, sir, it's okay. Attribute can be, number of attributes can be same. If they are not same, then obviously the relations are not union compatible. But if at all they are same, then is it always possible to union those two relations? No, sir. It may or may not be possible to union those relations. When exactly it will be possible to union them? Sir, it will be possible to union them if the domain of the corresponding attribute is same. So now, what do you mean by the domain of the corresponding attribute? By domain, I mean the corresponding values that can be taken by those attributes must be same. It should not be the case that one of them is one attribute is taking the integer value and another corresponding attribute is taking the character value. You cannot union integer and character. You cannot union integer and character. So these are the two prime requirements for two relations to be union compatible. They must have same number of columns and the domain of the corresponding columns must be same. Domain of the corresponding columns, attributes or columns must be same. So please try to understand. We are short of time, so I will not use the exact same relation, but I will give you a short introduction. That let's say assume that R is a relation in which A is one attribute, B is another attribute, And S is another relation in which there are certain attributes, let's say X, Y, Z. Yeah, so number of attributes. So first thing is number of attributes in R. Number of attributes in R are not equals to number of attributes in S. Therefore, not union compatible. So this case is not at all possible. If the number of attributes are not same, they cannot be union compatible. Another, take some time. This relation R, if I have something like this, so this relation one is SID, another is S name. It's okay. S. We have SID. Then we have marks of the student. Now what is happening? Sir, SID may be of integer. Let's say that SID is of integer type, and S name obviously will be of character type. S name will be of character type. Sir, SID here also is of integer type, but marks will also be of integer type. So please try to understand corresponding attribute. So first attribute SID and second attribute SID are having the same domain. But with respect to second attribute, domain is not same. Now what do we know? Sir, number of attributes in R and S are same. Number of attributes in R and S are same. So does it mean that they are union compatible? No, sir. Number of attributes in R and S are same, but domain of the corresponding attribute, domain of second attribute of R is not same as domain of second attribute of S. Therefore, not union compatible. Therefore, not union compatible. Sir, yeah, here the number of attributes are not same, therefore not union compatible. Number of attributes are same, but the domain of corresponding attribute is not same. Therefore, again, not union compatible. Sir, when exactly they will be union compatible? Come on, let's assume that this is your relation R. This is SID. Okay, sir. This is your S name. Come on. This is another relation. Now, please try to understand. You may get confused, but you may be like, that's this is the employee ID. So, what the relation with the student have to do with the relation employee? So, they have nothing in common. They have nothing in common. But the only thing that you must understand is that if the number of attributes are same and the domain of corresponding attribute is also same, then the relations can be union no matter what type of information they contain. No matter what type of information they contain. Clear? So, please, we all know so that this SID will be integer, this S name will be character. Here also, let's assume this is integer, this is also character. So, both conditions, number of attributes same, number of attributes are equal. Second, domain of corresponding attribute is also same. domain of corresponding attribute is also same. Therefore, union compatible. If it is the case, if the relations are union compatible, then you can perform the union of these two relations, you can perform the set difference of these two relations, you can also perform the intersection of these two relations. Clear? Hence, union, set difference, and intersection can be performed. And intersection can be performed. Very simple thing, sir. So, union, intersection, we all know. We all know that how union will be performed. We all know how intersection will be performed. We all know how set difference will be performed. But the very important thing is you must understand that when exactly the union, intersection or set difference can be performed. That's the most important thing. So, what will be union, sir? It contains all the tuples from each of the relation, obviously. Obviously. Come on, sir. Take some more time and explain this. No matter what. So please try to understand. Let's assume that SIDs are 1, 3, 5. Name is A, B, B. Here EID may be 1, 2, 3. The name of 3 may be B, name may be X, name may be A. Come on, sir. So if I say R union S, then R union S will take the name of its attribute from the left relation, that is SID and S name. That's an important thing. Please, this is very important that if you perform the union, what will be the names of attribute? Because R has different names of attribute, S has different names of attribute. The names of attribute in R are SID and S name, whereas the names of attributes in relation S are EID and E name. So what should be the final names of attributes in the union, intersection and set difference? So that we will understand. Sir, SID S name. So it will have 1A is okay, 3B is okay, 5B is also okay. So 1X is not already present, so add 1X. So 2A is not already present, so add 2A. So 3B is already present, so it will not be duplicated. 3B is already present, therefore it will not be duplicated. Now come on. Sir, this is R union S. What if I perform S minus R? What if I perform S minus R? If you perform S minus R, then the names of the attributes will be from the left side relation. Here the left side relation were R, therefore the names of attributes were same as the names of attributes in R, that is SID and S name. If you are performing S minus R, then the left side relation is S. Therefore, names of attributes will be same as EID and E name. So what is subtraction? The tuples which are present in S but not in R. 1X is present in S but not present in R. Therefore, 1X will appear. So 2A is present in X but 2A is not present in R. Therefore, 2A will also be present. So 3B is present in S. It is also present in R. Therefore, it will not be present in S minus R. So what is A minus B? Tuples which are present in A but not present in B. So that's the definition. So difference A minus B is the tuple which are included in A but not present in B. So here S minus R, the tuples which are present in S. So these 3 tuples are present in S, but among them 3B is also present in R, therefore it will not be present. Clear? Now similarly, if I say R intersection S, again R intersection, therefore the names of attributes will be same as names of attribute in relation R. There will be SID S name. There will be SID S name. Common tuple is only 3B. Please try to understand. So, what will be the names of attributes? Names of attribute in the resulting relation resulting relation will be same as names of attributes in left hand side relation of set operation. Clear? So in R union S, it will be same as R. S minus R, it will be same as S. R intersection S, it will be same as S. So it's perfectly fine that we have seen all the operations. Intersection, we generally know the concept of intersection, but it is a derived relational algebra operation that we'll discuss in the tomorrow's session. The last thing is rename operation. If you want to rename, let's assume the current name of the catalog is a catalog. If you want to rename with the name item supplied, so if you do this, there will be an aliasing. Catalog will be treated with the names items supplied. Similarly, in the supplier relation, we have SID, S name, and rating. If you want to change it to supplier number, simple name, and average rating, then you can do so. So if you want to change the names of the attributes, you will specify them within the bracket. Otherwise, you will simply specify the names of the name of the new relation. Now, what if you want to change both name of the relation as well as attribute? So to change the name of the relation, simply write item supplied without bracket. And in the catalog relation, there are three attributes: SID, PID, and cost. So we want to change SID into supplier number, PID into part number, and we want to change cost into price. So it can be done using this particular format. Clear? So these are just the rename operations. Don't worry, I have not given the example of these three operations, but they will be used very frequently in writing the different types of queries. So we will be visiting these concepts again and again. You will learn everything related to renaming of a relation or attribute or both. Now, the last thing, this is your homework problem. Let's assume that this is the catalog relation which contains this 5 tuples, and this is the part relation that contains this 3 tuples. Now my question is, retrieve SID of the supplier who supplied all parts. So this is basically division operation, but this is basically division operation, but I want you all to think about this, that how exactly you can write a query using basic relational algebra operation obviously. The question that will be asked in the GATE exam will also be using basic relational algebra operation 90% of time. So I just want to check how many of you can think that how exactly the required information can be retrieved by using those basic relational algebra operation. It will be time taking if you are not following any forum to look for the answer of this particular question. Even if you are following some forum, then also try to understand all the concept explained, so that in the tomorrow's session you will be able to understand this concept more clearly. So if at all you are looking here and there, please be alert while you are reading from the different sources. So these are the topics. From the next class we will understand intersection is done. It's simply, sir, how do we derive R intersection S? Sir, R intersection S is derived using set difference. That if you perform R minus S, then this will be R intersection S. Sir, I don't know. How did you do this? So this is your R. This is your R. And this is your S. This is your S. So what is this? So this is R minus S. This is R minus S. Right? So from complete R, if you subtract this, this will be nothing but R minus S. this is nothing but R minus S, and basically it's nothing but R intersection S. So R intersection S or intersection can be derived using set difference. Intersection can be derived using set difference. So that's not important thing. This is not an important concept. We all know how to calculate intersection, but for tomorrow's session, this too will be the most important topics. Yeah, we will require 1 hour duration to understand these two topics. So please, if you not already know these topics, then read from the different sources and attend the tomorrow's session so that you will be able to understand all the concept related to these two different types of derived relational algebra operation. That will be all for today's session. We have understood the basic classification of query languages, procedural query language and non-procedural query language. We have introduced the concept of relational algebra and we have understood different basic relational algebra operations. Clear? So that will be all for this session. If you guys have anything to ask, if there is any doubt related to relational algebra or SQL that you have in your mind, or if you want to ask anything related to topics which I have discussed in this session, then here is the time, or otherwise I'll wind up the session and I'll see you tomorrow with the derived relational algebra operations. If you have anything, please ask. Nothing, I believe. So, thank you very much. See you tomorrow, the same time, 6 p.m. to 7 p.m. with the concept of derived relational algebra. Till then, keep revising, keep learning. Thank you very much.